Welcome back. In the previous lesson, we defined the connection blueprint with interface def. We described a charging cable with type 10s and a resistance attribute. In this lesson, we finally use that definition to wire the system topology. This is where the parts, ports, and interface definition come together. We are saying that this charger is connected to this vehicle through these specific ports. That is where connection and interface usages come in. In SysML v1, connections were often experienced mainly through diagrams. You opened an internal block diagram, traced a connector line, and hoped the diagram showed the part of the system you cared about. That made topology harder to search, review, and compare over time. SysML v2 makes topology explicit in the model text. A connection can be declared directly, which means the architecture becomes readable, diffable, and easier to inspect without depending only on a diagram. For our charging example, we already have the ingredients: a supercharger, an electric vehicle, and a charging cable interface definition. Now we need a charging station context where the charger and the vehicle are actually wired together. The workflow is simple. We create a context that owns the participating parts. Then we identify the endpoints we want to connect. Finally, we declare the connection. For a general structural link between parts or items, you can use a standard connection usage, often declared with the connect shorthand keyword. However, when your connection strictly links ports together, you use an interface usage typed by an interface definition, which gives that port-to-port interaction its own identity and properties. The important shift is that topology becomes part of the explicit model semantics. Now we can put that into a charging station context. Let's walk through it. First, the package imports the definitions from earlier lessons. Charging system brings in the parts and ports from lesson 8 and 9. Interface definitions brings in the charging cable definition from lesson 10. Next, we create a context. This charging station owns the specific part usages that participate in this topology. Inside it, we create the two parts. These are not new part definitions. They are usages of existing definitions. This charging station has one charger and one vehicle, and the vehicle usage is named my car. Now we can connect their ports. This is the simplest form. It says that the plug port on charger is connected to the socket port on my car. The dot notation is important. It's called a feature chain in SysML v2. Charger.plug means start at the charger part usage, then navigate to its plug port. MyCar.socket means the same thing on the vehicle side. Feature chains let us describe topology textually, even when the endpoints are nested inside parts. The simple connect statement is useful when all we need to assert is connectivity. In a real model, we would usually choose either the simple form or a typed form. But in this lesson, we already have a specific cable definition, so we can make the connection more explicit. This creates an interface usage named charging session. It is typed by charging cable, so it follows the interface definition from lesson 10. The connection expects a charger side end typed by charging port, a vehicle side end typed by tilde charging port, and any connection properties defined by charging cable, such as resistance. The two end lines reference the actual ports owned by the local context. This part says that in this charging session, the charger side role is played by the actual plug on the charger. And this part says that the vehicle side role is played by the actual socket on my car. The interface definition gives us the blueprint, and the interface usage applies that blueprint to a specific topology. There is also a shorthand form. This expresses the same typed connection in one line. The longer form makes the end mappings explicit. The shorthand form keeps the model text compact when the mapping is obvious. Because the typed interface usage knows its definition, the tool has more to work with than a generic line. It can check whether the referencing ends conform to the expected port types. If someone tries to map charger side to another vehicle socket, the interface definition no longer matches the intended topology. It can also keep connection properties attached to the connection itself. The resistance belongs to charging session, not to the charger or the vehicle. This is the value of explicit topology. The architecture can be drawn in a diagram, but it can also be read, searched, version controlled, and validated in text. Before we wrap up, here's the V1 to V2 shift in compact form. In V1, the diagram often carried much of the topology story. In V2, the topology can be part of the textual model itself. Connector typing also becomes explicit. Instead of depending on a dialog box or a diagram property, the model text can state exactly which definition types the connection. When endpoints are nested, dot notation or feature chains give us a clean path to the port we want to connect. That is the main value of explicit connections in SysML v2. The system topology becomes a model element we can read, review, and validate directly. In the last few lessons, we defined ports, conjugated them, defined the interface between them, and then used that interface to wire a concrete topology. In the next lesson, we will examine what actually flows through these connections. We will move into item definitions, where data, electricity, material, and other exchanged things become first-class model elements. See you there.